Now, we've already seen that these two lines L1 and L2 in the previous part intersect at a point A. And in this part of the question then, it's asking us to find the acute angle between the lines L1 and L2, giving our answer to the nearest 0.1 of a degree. Well, let's suppose that this is the angle, theta. Okay, let's say it's that. Then that angle theta, we should realise from earlier questions similar to this, is always the angle between the two direction vectors. So if we were looking at the direction vector for L1, let's just put it on there, and the direction vector for L2, we can take L1, let's just take L1, we can drag it down to there, and we can take L2 and we can move it across to there. So you can see that theta is the angle between those two direction vectors. So when it comes to working out an angle between two vectors, we use the dot product or scalar product. We know that the cosine of that angle is equal to, just generally say, A dot B, all divided by the magnitude of the two vectors A and B. This is a result that you should know, and if you're unfamiliar with this, you can always just go on my website. There's tutorials on the scalar product or dot product as a way of finding out the angle between two vectors. But we need to define our vectors A and B that we're using, and my vector A is the direction vector for the vector for the line L1, so it's going to be -1, 2, 3. So let's just put that in as A is the vector -1, 2, 3, and the vector B I'm going to take is the direction vector for the line L2, the vector then 2, -3, 1. So when it comes to working out what cos theta is, we need to do A dot B, and we should be familiar with working out how to dot two vectors together. What you do is you multiply the components together and you add them. So in other words, you have -1 multiplied by the 2 here, and then we add it to the product of the j components, which will be 2 multiplied by -3, and then we add that to the product of the k components, 3 times the 1. And if you work this out, what we've got is -2 -6 plus 3, and that comes to -5. So we've got the top of the fraction here. Now we also need the magnitude of the two vectors A and B. So to work out the magnitude of a vector, all we've got to do is do the square root of the sum of the squares of the components. And you can strip off any negatives, it doesn't matter. You're just going to get 1 squared plus 2 squared plus 3 squared for the vector A. And this is the root of 14. So we've got the magnitude of A then is root 14. Now if we do the same for the vector B, then that's going to be the square root of the sum of the squares of its components, which is going to be 2 squared plus 3 squared plus 1 squared. 2 squared plus 3 squared plus 1 squared. And what we get again is the square root of 14. So that certainly helps make the calculation a lot easier, because all we've got to do now is just say that cos theta, if we use the dot product, cos theta equals A dot B, which we've seen is -5, and that's divided by the square root of 14 multiplied by the square root of 14. So in other words, we get that cos theta equals -5 over 14. So to get theta, it's just going to be the inverse cos of -5 over 14, -5/14. Now if you make sure your calculator's in degrees mode, just inverse cos that value, and you should find that you get 110.5 0.924 and so on degrees. Now clearly this is not an acute angle. What we found out appears to be this angle out here, and that can happen. Okay, when you've got two lines intersecting, you're going to have one or other of the angles. So we've got the obtuse angle here. So to get the acute angle, all we've got to do is take this angle away from 180 degrees. So therefore we can say that the acute angle, okay, is equal to 180 minus theta. And if we do that calculation, you'll end up with 69.075 and so on degrees. We've got to give our answer to the nearest 0.1 degrees, so this is going to equal 69.1 degrees to the nearest 0.1 of a degree, let's just say to 0.1 of a degree. Okay, so there you go, 69.1 degrees is that acute angle.